Okay, so this is 12.3, and this might be A. Not sure how many videos this is going to take. Yeah, let's call it A. Alright, second degree inequalities in nonlinear systems. That is a fancy way of saying we're going to look at what's shaded on a graph, and we're going to look at hyperbolas, parabolas, circles, and ellipses, and just to find out what's being shaded. So, for example, example 1, we have x squared plus y squared is less than 16. Well, I know that's a circle just because of what an equation of a circle looks like. Okay, but I don't know where it's going or anything like that at this point. So, what do we know here? We can draw this circle, but one of the things that we have to be concerned with is this inequality sign. Now, if this inequality sign were a less than or equal to sign, our circle would look round like that. If it has the equality sign off of it, it's just a less than sign like we have, it's going to be a dotted circle. Okay, so that's the way every one of these figures is going to be. If it has a less than or equal to or a greater than or equal to, it's going to be a solid circle. If it just has the greater than or the less than, it's going to be a dotted circle, dotted hyperbola, parabola, ellipse, whatever we've got there. So just something to be concerned with. So we know this one is going to be dotted, okay, because it doesn't have the equality sign underneath here. Okay, so we got that out of our system, so let's go ahead and graph this. Well, the equation of a circle is x minus a, the quantity squared, plus y minus b, the quantity squared, and it's usually equal to r squared. In this case, we're going to be using that, but that's the equation of a circle. And when a and b are 0, it's written this way, because you don't have to show x minus 0, you just show x. Y minus 0, you just show y. So when these don't exist, when a and b don't exist, like in this one, your center point is at the origin. So that's one thing I know, is that's at the origin. I also know that the radius, that the 16 is r squared. So if the 16 is r squared, r is going to be, what do we have to square to get 16? So it would be 4. Alright, so let's go ahead and get our graph on here. And make that smaller here. And we're going to graph that circle. Now remember, the circle's dotted because of this here. So we are going to put the center at 0, 0, and it's going to be at 4 as far as my radius is concerned. So I put a 4 all the way around there, and then I make this dotted. You know, it doesn't have to be perfect, because I'm just looking to make sure you're shading right, not whether or not you've got a perfect circle, although perfect circles are awesome. Alright, so this says this is less than the radius. So if it's less than the radius, it's going to be less than the radius, someplace in here. If it were greater than the radius, then it would be outside the radius of 4. Okay, but since it says less than, it's going to be what we have there in blue. And that's it as far as graphing that inequality. Okay, so there's example number 2. And what we're going to do with that is, alright, we'll move our graph up, and we're going to graph that. So we're going to make it easier just to do this. We put 0 in here, so 0 squared minus 2 is negative 2. We put a 2 in here, it's going to be 2 squared minus 2, so that's 2. Put a 4 in there, that's going to be 4 squared minus 2, that's going to be 14. Okay, so let's go ahead and start graphing that. 0, negative 2, 2, 2, 4, 14, it's going to be way up here somewhere. Let's try a negative 2. So negative 2 squared minus 2. So that's going to be 4 minus 2 is 2. So negative 2, 2. Alright, so after you get a few, you figure out that it looks like that. Alright, so what this is saying is that y is less than or equal to x squared minus 2. So because of the less than or equal to, we have a solid line there instead of a dotted. Now what we need to do is figure out, is the inside of this shaded, or is the outside of this shaded? That's what we're trying to do here. Okay, so what I normally do is I take my equation, or my inequality, and I pick a point. Doesn't matter which point. I'm going to pick a point inside this here. And if a point inside of there makes what I just did a true statement, then I shade in there. So I'm going to pick a point. Let's pick 0, 0 there. So if I put 0 in for y and 0 in for x, is that a true statement? Is 0 less than or equal to negative 2? No, it is not. So that means the inside is not shaded because that's not a true statement, which means the outside is what needs to be shaded. Okay, so it's a real easy process once you get your drawing done, is just to take the original equation, pick a point inside or outside. I usually pick like 0, 0 because it's the easiest, and if 0, 0 works, then everything else inside here works, and that's a true statement. If it does not work, like this one didn't work, that's not a true statement. That means that none of these points work, so the points that work are all the ones out here. Okay, so that's the quick and easy way to do that. Okay, so there's a hyperbola because of this minus sign right there. So let's just go ahead and real quickly solve this. There's no weird stuff going on, so I just need to divide everything by 36, which you already know how to do this, so I really shouldn't even have to do this. 4 over 36 is 9. 9 over 36 is 4, and that's 1. Okay, so I know my center is at the origin because I'm not adding or subtracting anything to that. So that makes that easy. Let's get this up here. Alright, so my center is at my origin. Okay, I've got a y of 3 and negative 3, and an x at 2, negative 2. So let's go ahead and make my box. And make my asymptotes. Okay, now because my y comes first, it's going to come in here. Okay, and notice this is a less than sign, so I can do this a lot easier than you can. It's going to be dotted. Okay, so is it going to be shaded inside my hyperbola or on the outside? Well, that's what I'm going to do here. I'm going to pick a point and put into my original equation. My original equation was 4a squared minus 9x squared is less than 36. So again, I'm going to use 0, 0. So 4 times 0 squared minus 9 times 0 less than 36. So 0 minus 0 is 0. Is 0 less than 36? Yes, it is. So that means 0, 0 works, right? Well, if 0, 0 works, then everything in the area of 0, 0 is going to work. So all of this is going to be shaded as doable, and none of this stuff in here will be shaded, not here or here. So none of the blue will be shaded. So let's get rid of it. Just what is there in the red. Okay, so let's do example 4. X squared plus y squared equals 4. Okay, and they're also giving you another equation here. They're both equations like that. Alright, well, that's a system of equations. Now, if you remember from, let's get rid of our graph right now, from the olden days, if there's not an exponent on your variable, it's a straight line. And hopefully you've been doing these enough that you realize that's a circle. So we've got a circle and a straight line that we're going to graph. And that's all it wants us to do. There's equal signs there, so we're not doing any shading. It's just asking us to solve. Alright, now, when you're given equations where one has exponents and one doesn't, you cannot do elimination. You have to do substitution. So we're going to take the simplest equation and set it equal to one of the variables. So we'll make that, okay, we'll add 2y to both sides and we get that. Okay, now we're going to take the top equation, and wherever we see an x, we're going to put 2y plus 4. Okay, FOIL method. Plus. Now I'm assuming I don't have to go through and do this for you anymore, that you know that 2y plus 4, the quantity squared, you've got the first one, and you get the 4y squared. Outside you get 8y, inside you get 8y. Add those up and you get 16y, thank you. And then last gives you this 16. Okay, so get rid of all this junk here. And okay, that y needs to go back there. Alright, so now that we have that, let's start combining things. This and this can combine to be 5y squared plus 16y plus 16 equals 4, right? Okay, now we can make 2 parentheses. And, well, in fact, let's not make our 2 parentheses yet. We've got to set this equal to 0 before we do that. There. Okay, so there's our equation. Now we have to solve for y. Okay, you can use Pythagoras, or you can use a quadratic formula if you would like, or you can factor it into factors by taking, remember, you take this times this, and you get 60. So now we're looking for two numbers multiplied together that give me 60, added that give me 16. So what do we have? 12 times 5 is 60, 10 times 6 is 60. 10 times 6 works because 10 times 6 is 60, and added together gives me 16. So I'm going to use that. And remember, instead of writing 16, you write 10y plus 6y, which is these two numbers here. This is from a while back. Okay, and then we parenthesize things. Okay, forgot the 2 there. Okay, so we pull out a 5y and we're left with y plus 2. Pull out a 6 and we're left with y plus 2. And that gives me a 5y plus 6 times a y plus 2. And we'll finish this in the next video.